Welcome back to your third video of 3 for these OWLS videos. Today we have a jam-packed video full of really cool information about the Columbia River Gorge, where we live, and how it's changed over time. So before we get started, let's do a quick review of the last video. So if you remember, our last video, we got a little wild. We talked about, what did we talk about? Oh yeah, we talked about survival. We talked about how plants and animals use adaptations to survive in their habitat. So we talked about what adaptations are, how organisms can have adaptations, and then how animals can have adaptations and they can also do adaptations. So we talked about physical adaptations, we talked about behavioral adaptations. We also talked about what a habitat was. So we defined a habitat as a place where an organism can find its food, water, and shelter. Sit back, relax, and get ready for your final video. Let's get to it.
Hi there, and welcome to your third and final lesson of OWLS. Today we're going to talk about how the gorge has changed over time. Over time, everything changes and nothing stays the same. And there's a lot of different reasons why these things change. And in order to understand that, we first need to talk about the Earth and some various ways that it changes over time. The Earth is made up of what we're going to divide into 4 different spheres. And you might have heard of some of these before. These spheres include the biosphere, atmosphere, geosphere, and hydrosphere. The way that these 4 spheres work together create the changes that we see in the world. So let's break down each of those spheres a little bit and try to understand what they mean. So let's start with the biosphere. Biosphere has the prefix bio, like bio in biology. And bio basically means life. Biology is the study of life. So the biosphere is basically everything on Earth that is alive, or includes organisms. So we learned in our first lesson that an organism is any living thing. So the biosphere is made up of all of the living things on Earth, all of the plants and animals. Next we have the atmosphere. The atmosphere is basically all of the air that is surrounding the Earth. And there's a few different layers to the atmosphere. But it's basically everything that is up in the sky. So that's where the clouds are, that's where the birds live, that's where some of the pollution on the Earth gets held. The atmosphere is also closely connected with the hydrosphere. The hydrosphere has the prefix hydro, which means water. If any of you guys have ever heard of those hydro flask water bottles, hydro flask, hydro's water, flask is like a container. So hydro means anything with water. So the hydrosphere on Earth is all of the places that contain water. So that's oceans, rivers, lakes, even clouds are made up of water vapor. So they are included as part of the hydrosphere. Next we have the geosphere. The prefix geo means rock. So that's everything on Earth that is made up of rock. And the geosphere is not alive, right? Because we know that rock is a non-living thing. So the geosphere has to do with the crust of the Earth. It has to do with the mantle underneath the crust that erupts and forms new rock on Earth. So anytime you hear of any part of the Earth related to rock, part of the geosphere. So the interaction of these 4 spheres are how we see changes on Earth. One way that the Earth goes through changes is through a process called plate tectonics. Some of you might have heard of this before. Plate tectonics has to do with the crust of the Earth and how it changes over time. So the Earth is divided into different pieces of crust. The crust, we learned, is the outermost layer of the Earth, and it sits atop a layer called the mantle. Underneath the mantle is the core. So those are like the 3 main layers of Earth. And the crust is divided up into different pieces called tectonic plates. And these pieces kind of fit together like a puzzle. And I like to think of tectonic plates the tectonic plates in this metaphor where we have a pot of boiling water. And on top of that pot of boiling water, we have different pieces of bark or wood chips. And these wood chips are moving around on that boiling water, and as they do that, they're bumping into each other or moving away from each other. This is similar as to how those tectonic plates are interacting. Sometimes they're coming together, sometimes they're moving apart, sometimes one might go on top of each other or underneath the other one. So there's different ways that these tectonic plates interact, and we're going to go over a few of those. When two plates come together, it's called a boundary. So now let's dive in and talk about what those different boundaries look like. The first one is where we have two tectonic plates that are moving towards each other. This is called convergent, a convergent boundary. We have two plates that are converging. And what happens there is they come up towards each other and they grow upwards like this. These miles and miles of rock of the crust are coming together and moving upwards, and this creates mountains. The largest mountain range in the world are the Himalayan mountains, and that's where Mount Everest is. And that's where two continental plates are coming together and they're creating mountains. The second type of boundary is basically the opposite, where you have two plates that are moving apart. So these plates are made up of miles and miles of rock, and underneath those layers of crust is the mantle. And the mantle is a molten layer. So that means it's basically made up of magma. So when these two plates come apart, that makes way for the mantle to come through. And it's a very slow process, but basically that mantle is slowly building and building up new rock on the surface of the earth, so more land is created. The third type of boundary is called a strike-slip boundary. So what's happening there is you have two plates that are coming together, and to demonstrate this, I'm going to use my fists. They're coming together, and one is moving up, and one is moving down. So I'm going to push my fists together and move one of them up and one of them down. And when I do that, there's lots of pressure between the two. But because I'm moving one up and one down, eventually I get this slip that happens. That's why it's called a strike-slip boundary. And that's what's happening with some of these plates. There's all of this pressure building up of all of this rock. For a long time, nothing will happen, but that pressure is building and building and building, and then eventually, it slips. And what happens then? Earthquakes. In California, there is one of these strike-slip boundaries called the San Andreas Fault. So at the San Andreas Fault, there are lots of earthquakes that happen. And that's because these two plates are building and building and building up pressure, and then eventually they slip. And when that slips, it causes the earth to shake like an earthquake. The fourth type of boundary is called a subduction zone. And this one is the one that applies to us here in the Pacific Northwest the most. So in a subduction zone, you have two plates that are moving towards each other again. But in this case, the two plates are different densities. So one of them is an oceanic plate, so that means that it has an ocean on top of it. And the other is a continental plate, which means it's made up of land. And one is more dense than the other. So it slips underneath. And what happens is that rock is moving further and further down towards the mantle. And as it moves towards the mantle, it heats up and melts. Some of that rock melts. And then there's this heat and pressure that happens underground, and eventually that melted rock comes to the surface and a volcano happens. So we live in a section of the Ring of Fire, which is basically a circle around this oceanic plate where there's all sorts of subduction zones that are going on. So there's a lot of volcanoes. So a lot of the mountains around here are actually volcanoes. Take a minute to think of a volcano that is close by. I know that I live close to Mount Hood, which is a volcano, and Mount Adams is also close by, and that's a volcano too. These different fault lines and interactions of tectonic plates create lots of changes in the Earth. Now that we've learned about some of the ways that the Earth has changed over time, let's zoom in and specifically talk about how the Columbia Gorge has changed over time. So as we're going through this next activity, pay attention to those four spheres that we learned about and how they're working together to create changes in the gorge. Also pay attention to the fact that this area is a subduction zone and the impacts that that has had on the changes in the gorge over time. Let's get started.
So here I have a map of Oregon and Washington.
And as you can see, there's a little green box there, and we're gonna zoom in. So as you can see on the left, that is representing the west, and that is the Pacific Ocean. And here we have the Columbia River, which cuts right through the Columbia River Gorge. And you can see the little dot that's representing Portland and the dot that is representing the Dalles. We're going to do a little demonstration seeing how the gorge has changed over time. I have this blue felt board, so that blue square is the same area as that green square. Okay, so the reason that this square is blue is because millions of years ago, this whole area was underwater. Which sphere is water a part of again? The hydrosphere. That's right. Okay, so why aren't we underwater anymore? That's because these tectonic plates that we talked about are always moving. Great, now we have some land. So the top section of fabric is representing a piece of Washington, and the bottom one is representing a piece of Oregon. And that little strip of blue in the middle is where the Columbia River will be. But millions of years ago, there did not used to be a river there. So we're going to cover it up. That's more what it looked like millions of years ago. So what else happens when plates move around? We get volcanoes because we live near a subduction zone. So up there in Washington, we have Mount Rainier. And another one in Washington, we have Mount Adams, and that's pretty close to the town of Trout Lake. We'll put that about right there. It's closest to me, we have Mount Hood. And there's one other one that's a little bit further west. That is Mount St. Helens. And Mount St. Helens erupted not too long ago, so it has a removable top. Millions of years ago, that top is still on there. So there are the volcanoes that are present in the Columbia Gorge, formed by subduction zones. Besides volcanoes, is this whole land flat? I don't think so. I think there's lots of hills and valleys and things like that. Oh yeah, there's some nice topography, some elevation change. So around this time, there was a big rush of water that came from the east and scoured out the Columbia River. So to represent that, this strip comes off. And now we have our Columbia River. Later on, there were some massive lava flows that happened and started building up some fresh rock along the banks of the river. So to do that, I'm gonna lay out some strips of felt along the banks of the river. Oh yeah, and this is what eventually created those steep walls and cliffs along the Columbia Gorge. All right, so we got some geosphere with those rocks and mountains. We've got some hydrosphere with the ocean and the river. What are we missing? We're missing a little biosphere. Here on the western side, we have a little bit of more green vegetation because, as we talked in our first lesson, there's this thing called the rain shadow effect that causes it to be more green, more forested on the western side of the gorge and drier on the eastern side. Bloop, 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 bloop. There we go. Soon after this, something pretty crazy happened. There was a massive lake way over here in Montana in Canada. And it was held up by a big wall of ice. And it kind of caused a dam. And eventually that ice dam broke. And when that happened, a huge wall of water came rushing through the Columbia River. And it made this river a lot wider, and it carved the walls to be much steeper. So to show that event, what I'm gonna do is I'm gonna fold these under to show that we have some steep cliffs going on. There's our nice steep cliff walls. All right, so while all these changes were going on, a few other things were happening too. So there were a bunch of other rivers and streams that started flowing into the Columbia and around the Columbia. So we've got all sorts of different rivers. There's one that flows from Mount Hood into the Columbia, which is called the Hood River. We've got the White Salmon, which flows from near Mount Adams into the Columbia. We've got the Klickitat River over here, and a whole bunch more too. I'll even throw some lakes on there. Pew! So now we've got some rivers, got some lakes, got some salmon in the river, very important to the history of the gorge. And I know that salmon swim out to the ocean, so we'll put some salmon in the ocean too. Maybe put a rabbit in the shrub steppe. They like to hang out there. Bumblebees. Maybe they'll be in some wildflowers in the shrub steppe. Let's pretend this is a rattlesnake hanging out in the shrub steppe. A bald eagle. I know they like to fish near the Columbia so they can get some of these salmon. Got another bird. That guy can do some fishing too. I know there's some bears in the forest near Mount Hood. So all sorts of animals and plants. The first people arrived in the gorge about 10,000 100,000 years ago. So people have been here for a very, very long time. And for a long, long time, those people really didn't have that much of an impact on this land. It stayed looking like this for a really long time. And it wasn't until about very recently, about 200 years ago, when the first non-native people started arriving to this land and really started to change what it looks like and started to make it look more like it does today. And when they came, they made a lot of changes. Think for a minute about what sort of changes these people might have caused. So let's zoom in and take a look. So over here near where Portland would be, I cleared away some of that green vegetation, so all those trees, and added some buildings. Portland is a city. This way I know this is where a major freeway goes. I cleared some more vegetation, added some more buildings up near Tacoma and Olympia. Along the Columbia Gorge, I added some more houses because I know there's lots of towns along the Columbia Gorge. Added some people there. Humans built dams on the Columbia River and the Snake River in order to harness electricity from the power of the river. Though this was a great way to develop the economy and to get some clean energy, it really affected the salmon that make their home in the river. And it also influenced the water level of the Columbia River. Also, by all of this development, we might have impacted some of the other animal species in the gorge as well and put them at danger because we were getting rid of some of their territory. So take a minute to think of some other changes that humans might have caused over time in the gorge. What changes do you think will happen in the future? How can we be good stewards of this ecosystem? How can we protect the animals, the plants, and the water that were here before us? The gorge has changed a lot over time, and it's going to continue to change in the future. Let's remember to be good stewards of this gorge so that it can be a great habitat for the organisms and the people that it is traditionally home to.
Hey, what's happening? Steelhead back here for our last video together. Today we're gonna be learning a good bit about how the Columbia River Gorge was formed, checking out some lava flows, and just sort of thinking about how all of the land and the air and the water and the plants and animals, how all of that is connected. So we have a couple activities to do. Before we get started, I want to acknowledge the land where I'm gonna be today. I'm gonna be going to a couple of different areas, and the land where I'm gonna be today is all land that was originally inhabited by indigenous people that are now part of 4 different major tribes. These tribes were all part of the Columbia River culture and diet and language, and so the people of the Nez Perce tribe, people of the Federated Tribes of the Warm Springs, the Confederated Tribes of the Umatilla, and the Federated Tribes of the Yakima. So I just want to thank those tribes that have and continue to steward all of this land, and I recognize that I have a pretty big responsibility to continue that stewardship and to mend the relationships. Now, when we're thinking about the Earth, and the Earth has these 4 spheres, right? The biosphere, bio is life, hydrosphere, hydro is water, atmosphere, referencing the air, and the geosphere. Geo means earth or rocks. What we're gonna do is, thinking about these 4 spheres, we're going to develop a model that is gonna show how at least 2 of these 4 spheres are interacting. So we're thinking about the biosphere, atmosphere, geosphere, and hydrosphere. Living things, air, water, and land. To do this, what I've done is I've found a beach along a river. I'm just collecting things on the ground. I don't need any special tools. This first activity, we're gonna build this big volcano and essentially create a river. We're gonna add plants and animals, and we're gonna see how the different spheres of the Earth are connected, at least 2 of them. So let's get started. All right, so I already have an example. I've already developed a model of how the geosphere and the hydrosphere interact and are connected. Okay, I've made my volcano, and I have a river flowing down out to the ocean. I'm pretending that's the ocean. As I watch this river, as I watch the water go up and down this river, I notice that the water is changing the formation of the river. And that's true of all of these rivers. The Columbia River doesn't stay the same. It changes constantly. The sandbars change. Miller Island, that sand is constantly shifting around. Now, it doesn't only shift because of the water, it also shifts because of the air moving past it. So if this sand was drier, it would be getting blown around with the wind that's blowing. All right, we can continue to watch this river change. So the hydrosphere and the geosphere are interacting with one another, and that is causing change. As I watch this, it's every minute it's changing. As a human, as part of the biosphere, I could change this river if I wanted to. I could dredge it out maybe. I could block it up. Let's see what happens if I put a dam in here. The Deschutes River doesn't change that much really because it's controlled by dam. Now I've put a little dam, let's see what kind of changes happen. Okay, this seems pretty interesting. Since I've put the dam in there, I haven't noticed as many changes, just like the Deschutes River or the Columbia River. Before the dams, they changed often. The Klickitat River changes often. The Hood River changes often. The White Salmon now changes pretty frequently. Those rivers don't have dams on them. The Deschutes, the Columbia, some of those rivers that do have dams, they don't change as much, just like my model is showing. All right, well, we're gonna take the dam out. So we have the geosphere, the biosphere, and the atmosphere. Right now, the atmosphere isn't causing a whole lot of change to my model. Like I said, if I had dry sand, maybe I'll put some dry sand up here to see how that changes, how the atmosphere might interact with the geosphere there. The atmosphere is interacting with the hydrosphere, so water is coming off the ocean, getting blown over into the mountains by the atmosphere. As the clouds, as the hydrosphere, as those clouds hit the mountains and start rising, they're not able to hold on to the moisture, so that's when we get precipitation, and we call that the rain shadow effect. That's why we have dense forests near the coast, and over by like Cascade Locks in Portland, there's dense forests. And then once we get out, by the Dalles and Wishram and Dallsport and Lisle, then we start getting more into the shrub steppe ecosystem where it's a little drier. Cascade Locks gets about 80 inches of precipitation each year. The Dalles gets about 20 inches of precipitation each year. So quite a bit of difference with the hydrosphere, and that affects the biosphere. All right, now I've added just a little bit to the biosphere. I added these plants here. We already talked about the rain shadow effect and how different organisms are spread out because of the availability of water. Well, erosion comes into play with the biosphere as well. If there are plants along a riverbank, then there's not going to be as much erosion. If we don't have plants, then we will have erosion. And so erosion is the gradual breakdown of Earth's materials. Erosion can be caused by water, could be caused by gravity, could be human caused, could be caused by animals. So a lot of different things could cause erosion. All right, well, that's the first activity, is create the mountain and the river, look at how the hydrosphere and geosphere are interacting, maybe see if the atmosphere is interacting with it at all, then trying to add into the biosphere and thinking about how these are all connected. Now, our next activity, we're gonna sort of a scavenger hunt, but this is a long-term thing. A lot of these are kind of long-term, do it over and over. But this one is, you're gonna be looking for evidence of lava flows, and you're gonna be looking for columnar basalt. So I'm gonna go to a few different spots that I know of where you can definitely see it. We'll see if you recognize any of these spots, and off we go. There's a really good example of columnar basalt. Let's see if you can find this columnar basalt. How it has the kind of the brick shape that goes up and down like a pillar. Those lines in there, that's what we call columnar basalt. And so that tells me that that lava cooled off slowly. So it must have had more lava flows on top of it at one point, and maybe those lava flows were washed away in the floods. And as I'm looking at this, I'm seeing at the bottom, below the columns, I see more kind of jumbled lava flow. So maybe that cooled off quickly. Then a couple hundred years later, or 1,000 years later, or whatever it was, more lava flowed on top of it, and more lava flowed on top of that, creating the jumbled pattern at the bottom, and then the columns going up on top of there. All right, here we have a super cool lava flow. Some great columnar basalt that's also kind of bending. So I'm not sure what must have happened to form that, but that'd be interesting to find out. Why did it cool off and form that way? Why did that lava look like that? Why do you think, Butterfly?
Full of lava. Because look how high that is of lava.
More lava flow. Okay, and your last activity that you're gonna do is, I'm doing this just right outside of where I live, and so you're just doing this right where you are. And it's actually the same activity as we did in the very first video, the very first activity, where we found a spot where we could sit or stand for at least 10 minutes by ourselves, totally silent. But this time what I'm doing is, as I sit here, I'm thinking about the history of this place and thinking about the first people and what life was like here 10,000 years ago. Thinking about what it might have been like if we were around when the floods happened. Thinking about what it was like here 200 years ago. Maybe the last time that a volcanic eruption occurred around here, and thinking about what that was like. Thinking about how things are going to continue to change. Thinking about the change that I've seen just in my lifetime here. I've seen a lot of rock falls, I've seen floods, I've seen widespread disease, I've seen I've seen a lot of changes. I've seen a lot of changes caused by humans. I've seen a lot of changes that occur naturally. I've seen big fires. So thinking about those changes, thinking about what changes might occur in the future, and thinking about how I can be a positive agent of change in the future. All right, well, I hope you all learned something. Hope you had fun with these videos, and make sure you're doing the journals and the links, and I hope we can meet in person someday. Just want to remind everybody to make sure you're taking care of yourselves and taking care of those that you're close to. And I just want to wish you all well and enjoy summer.